Good morning. In this video, I would like to explain about small sample test. In the small sample test, I would like to explain about chi-square test for goodness of fit and chi-square test for independence of attribute. Now, let us see the procedure of chi-square test for goodness of fit. So, in our day-to-day life, we are having some observed values and we are having expected values. It means that before expectation, so before writing an examination, we may feel that we are getting some out of 100, we may get some 60, 70, depends upon the study, whatever the level. So, now that is what we call it as observed frequencies. Expected, it means after the experimentation is over, we are getting some values. Now, this chi-square test for goodness of fit is, we are going to finding out the discrepancy between the observed frequencies. We are going to finding out the discrepancy between the observed frequencies and expected frequencies. So, this is before expectation, we are assuming, we are expecting some values. So, expected frequencies. So, this is after expectation, after experimentation, we are getting some values. This is what we call it as expected frequencies. So, now we are finding to test whether there is any significance difference between observed frequencies and expected frequencies. So, this is what we are going to finding out by using chi-square test. So, chi-square is summation I from 1 to n OI minus EI whole square by EI. So, in the given problem, we are having n observations. If having n observations, we are going to finding out the test, the degrees of freedom, it will be n minus 1. Here, the degrees of freedom means the number of independent variates which make up the statistic. It means at what level we are going to give the conclusion. So, here n is nothing but the number of independent variates. It means the given problem, it contains n is equals to 5. It means n minus 1 means we have to follow the table value of 4DF at 5 or 1% level of significance. We have to conclude this test is to be suitable or not. So, now here we are going to finding out by using the 5 steps process of testing of hypothesis. Like the first step is null hypothesis. So, null hypothesis, it will be denoted by H naught. So, H naught means there is no significant difference in the given data. So, whatever the data in the given problem, we are assuming that the data is correct. So, actually it is of the small sample test. So, what is small sample test? If the sample size value n, it should be less than 30, it will be a small sample test. So, for what purpose we are doing? Suppose we are going to check whether this data is right or wrong. So, the first step we are taking it as null hypothesis H naught. So, what is H naught? Here we are assuming that there is no significant difference in the given data. There is no significant difference in the given data. So, whatever the given problem we are having, we are taking it as it is. That is, there is no significant difference in the given data. So, next step is alternative hypothesis. So, alternative hypothesis means the statement against the null hypothesis. It means that there is some significant difference in the given data. There is some significant difference in the given data. There is some significant difference in the given data. This is what we call it as alternative hypothesis. The third step is the level of significance. So, we are choosing the level of significance. If the problem, if they won't mention anything, we have to follow the level of significance, it will be 5%, or if they mention anything, we can follow with 1% level of significance. Now, what is fourth step? This is what we call it as the test statistic of chi-square. So, this is calculated value of chi-square. Now, let us see the fifth step of the conclusion. So, the entire process we are going to verify whether this data is right or wrong. So, how to make conclusion? This calculated value of chi-square is less than table value of chi-square. The calculated chi-square is less than the table value of chi-square. The thing is, we are accepting H naught. So, accepting H naught means whatever the given data we collected, so that data is completely we are accepting, that is the correct data. If any case, some of the given problems, if the calculated value it should be greater than the table value of chi-square, then we have to conclude that we reject the data. It means that there is some significant difference in the data. That means that we collected a wrong data, we have to stop the process and we have to go through with another data. So this is the process of chi-square test for goodness of fit. Now let us see the problem on chi-square test for goodness of fit. A die is thrown 264 times with the following results and show that the die is biased. Now we are having in the given data, we are having the number appeared on the die and we have with the frequency values. So as we observed that if you are tossing a coin, we have 2 outcomes. If you are throwing a die, we have 6 outcomes. For these 6 outcomes, now we are having the frequency values. So as per the testing of hypothesis process, we are going to solve this problem by using 5 steps. The first step now, it is of null hypothesis. So we discussed before in the last videos, null hypothesis means a statement of no difference is called null hypothesis. So in this null hypothesis, we are going to define the null hypothesis H naught is. So what is our given question? Show that the die is biased. So we know the meaning of biased means with partiality, we are throwing a die. So we are taking that the null hypothesis H naught is the die is unbiased. The die is unbiased. So it means that without partiality, we are throwing the die. So this is what we call it as a null hypothesis. Now let us see the second step, alternative hypothesis. Alternative hypothesis, it is denoted by H1. So a statement against the null hypothesis is alternative hypothesis. Now we are taking the null hypothesis is the die is unbiased. So the alternative means the statement against the null hypothesis. So this is what the die is biased. So now in the given problem, they did not mention anything about the level of significance. So if they did not mention anything in the level of significance, we should prefer at 5% level of significance. So here the level of significance is 5%. So now we are having only observed values and we are having the expected frequencies. So chi-square test for goodness of fit, here we are going to finding out there is test whether there is any significance difference between the observed frequencies and expected frequencies. So now we are going to define the formula of chi-square test. That is what we are going to define it as a test statistic is defined by chi-square is equals to summation I from 1 to n OI minus EI whole square by EI. So we are having an observation, so that it follows chi-square test for n minus 1 degrees of freedom. So it is nothing but the number of independent variates which make up the statistic. This is what we call it as chi-square test for the degrees of freedom. So now here we are going to define about the observed frequencies and we have with an expected frequencies. So in order to prove this analysis, we are going to take a tabular form of OI minus EI and the next column as OI minus EI whole square and the next column as OI minus EI whole square by EI. So now the observed frequencies here, it is on, that is what we are going to consider it as the frequencies. The frequencies are now 40, 32, 28, 58, 54 and 52. So this is what we call it as the observed frequencies. So in order to finding out the observed frequencies, we are finding out the sum of all the observed frequencies. So this is what we are going to define it as 264. So now how to finding out these expected frequencies? So the observations 264 by how many number of observations we are having? 6 observations. So we are going to define it is 264 by 6 is 44. So each expected frequencies we are going to consider it as each EI value, it will be only 44. So we are writing the expected frequency of each of these observation, it will be 44 only. So now it will be 44, 40 minus 44 is minus 4 whole square, it will be 16. OI minus EI whole square by EI. So it will be of 16 by 44, it will be 0.3636. Now let us see the next one, 32 minus 44, it will be 12. So 12 square, 144, OI minus EI whole square by EI, 144 by 44, it will be 3.2727. And the next one, 28 minus 44, it will be 16. So 16 square, 256. OI minus EI whole square by EI, 256 by EI value, it will be 44. So it will be 5.8181. So, the next one 58 minus 44, it will be 14, 14 square, 196, 196 it will be what? 4.4545, y minus ei whole square by ei. Next y minus ei whole square, 54 minus 44, 10, 10 square it will be 100. So, 100 by ei it will be 4.44, so it will be 2.2727. And the next one is 52 minus 44, it will be 8, so it will be 64, 8 square is 64, 64 by ei is 44, so it will be 1.4545. Now, let us see the summation of this last column. This is nothing but we are going to finding out the summation of y minus ei whole square. The sum of all these observations, it will be 17.6362. So, we are going to finding out about the conclusion. This is what we call it as a fifth step. So, the conclusion, it will be the calculated value of chi square. We are going to define about the calculated value of chi square is 17.6362. So, before that we define it is the degrees of freedom, it means the number of independent variates which make up the statistic. So, this is number of observations in the given problem. Here we have 6 observations. So, we are going to define about the table value of chi square for n minus 1 df. So, it will be of n minus 1 df, it will be 6 minus 1 is 5 df. They did not ask anything. So, we are taking it as the level of significance is 5%. So, it will be of 0.05. So, 5 degrees of freedom at 0.05. So, it will be what? So, 5 corresponding we are going to check the table value is 0.05. So, you see this is the degrees of freedom 5 with the corresponding 0.05, it will be 11.07. So, now we have to conclude this calculated chi square is less than the table value of chi square. So, it will be 17.6362, we are going to compare it with the table value is 11.07. So, the value it should be a greater value. So, our conclusion it should be calculated value of chi square is greater than the table value of chi square. So, as per our 5 steps process, if the calculated value of chi square is greater than the table value of chi square, we are going to conclude that we reject H naught. So, what we are taking it as H naught? H naught is the die is unbiased. So, we are rejecting means we are concluding that therefore, the die is biased. Therefore, the die is biased. So, in this way we are going to finding out to test whether there is any significance difference between observed frequencies and expected frequencies. Thank you.